What lies beyond the edge of the universe? It's a question that has puzzled scientists, philosophers, and dreamers for centuries. We look up at the stars and wonder if the universe has a limit. What's on the other side? To begin with, we need to understand the scale we're dealing with. The observable universe, the part we can see, is about 93 billion light-years in diameter. That's staggering, especially when you consider the universe is only 13.8 billion years old. How can we see something that far away? The answer lies in the nature of space itself. The universe has been expanding since the Big Bang, and it's not the galaxies flying away through space. It's space itself that's stretching. That means light from objects far away is only just reaching us now, even if they're much farther than 13.8 billion light-years. But the key word here is observable. That's only what we can see. There could be far more out there, billions of galaxies, stars, and cosmic structures that lie forever beyond our reach because their light hasn't had time to arrive. So what's beyond the observable universe? Is there an edge? A boundary we might one day reach with enough technology or time? Surprisingly, most cosmologists say no. There is no edge to the universe in the way we might imagine. One possibility is that the universe is infinite. It just goes on, with no end and no boundary. In that case, asking what's beyond it is like asking what's after infinity. It doesn't end, so there's nothing beyond. Another possibility is that the universe is finite, but unbounded. To understand this, imagine the surface of a balloon. If you're a tiny creature walking along that surface, you could keep going forever without hitting an edge. Eventually, you'd circle back to where you started. This balloon model is how some scientists describe a closed universe. It has no edge, but it's still limited in volume. It's like a looped video. You never hit a wall, but you're still moving within a confined structure. Now let's throw in some real science. Observations from NASA, SWMAP, and ESA Planck satellite have measured the cosmic microwave background, the afterglow of the Big Bang. These measurements strongly suggest the universe is flat, with only a tiny margin for error. A flat universe means space extends in all directions like an endless sheet. If that's true, then there may be no limits to space. It just keeps going and will never find an edge because there isn't one defined. And yet, this raises a deeper question. If the universe is infinite, does that mean it contains infinite versions of you, Earth, and everything you know? That's where we enter the domain of the multiverse theory. According to some versions of inflationary theory and string theory, our universe might be just one bubble in a vast cosmic ocean of universes. These pocket universes could have completely different laws of physics, constants, even dimensions. M-theory, an extension of string theory, suggests there could be up to 11 dimensions. Some of them might be curled up so tightly that we'll never detect them. Others could be unimaginably vast. In such a landscape, our universe is just a speck. So if other universes exist beyond ours, could we ever reach them? Current physics says probably not. The space between these universes may be expanding faster than the speed of light, making them forever unreachable. Even within our universe, the expansion is accelerating. Thanks to dark energy, galaxies are moving away from us faster and faster. Eventually, some will move away faster than the speed of light, and their light will never reach us. That means the observable universe is shrinking in a way. More and more galaxies are disappearing over the cosmic horizon, and we'll never see them again. But back to our main question. Is there an edge we could stand at, look over, and see nothing? In the physical sense, probably not. There may be regions where space-time ends, but no cliff, no barrier, no cosmic wall. Some physicists even argue that asking what's beyond the universe is meaningless, just like what's north of the North Pole. It's a question that breaks down because the concept doesn't apply. If space and time themselves were born in the Big Bang, then nothing exists outside them. There's no before, no after, no outside, because those dimensions didn't exist yet. It's possible, too, that we live in a simulation or a holographic universe. Some scientists are seriously considering the idea that reality as we know it is projected from a two-dimensional surface, meaning the edge is more of a code limit than a physical one. The truth is, we don't know what lies beyond the universe because we may never be able to know. Our tools, our minds, and even our physical laws may not be capable of accessing that knowledge. But that's the beauty of science. Every time we look deeper into the universe, we discover something new. From quasars to dark matter, from black holes to gravitational waves, the cosmos keeps surprising us. So maybe the real answer I send to about what is beyond the edge, but how far we willing to push our understanding to even get close. And maybe, just maybe, the edge of the universe I send out there in space, but inside the boundaries of our own imagination.